We're now solving logarithmic equations where the logs are focused on one side of the equation and there are no logarithms on the other. In this case, what we'll want to do is condense the logarithms that are on one side into a single logarithm and then convert the equation into exponential form. So let's begin by condensing these two logarithms, and we're going to use our product rule in reverse essentially because these two logs are added together. So when we condense them into a single logarithm, we'll keep the same base that both logs have, which is the implied base 10, and then in the argument we're going to multiply the arguments of the two logarithms together. So that's going to be x times x plus 3, and we're still equal to 1 on the other side. After we've condensed into a single logarithm, now it's time to convert into exponential form. To convert a logarithm into exponential form, we need to start with the base, which in this case is 10, and draw a counterclockwise circle from there saying 10 raised to the first power is equal to the argument, which is x times x plus 3. So we have 10 raised to the first power, which is x times x plus 3. After we've converted to exponential form, we want to reassess and determine what type of equation it is now. Hopefully we can recognize that this one is quadratic. And when we recognize an equation as being quadratic, it's best to set that equal to 0 so that we can then decide which method we'd like to use to solve the quadratic. So we'll start by distributing the x into the parens, and then we'll subtract 10 from both sides. Let's also reverse the side so we get x squared plus 3x minus 10 on the left and 0 on the right. Now we can see that this quadratic factors. This trinomial factors into x plus 5 times x minus 2, and when we set each factor equal to 0, we get x is equal to negative 5 and x is equal to positive 2. So we've solved the equation, but we now need to check the final answer. Remember, logarithmic equations can sometimes generate extraneous solutions, so it's very important to check our answers, especially in logarithmic equations. So let's start by checking x is equal to negative 5, and when we check an answer, we want to check it back into the beginning equation, not in step 2. Sometimes an extraneous solution would work in the second step, but if it doesn't work in the first step, it's not actually a solution. So we'll take it all the way back to the beginning, log base 10 of x plus log base 10 of x plus 3 is equal to 1. And when we plug negative 5 in for x, we see that we get a negative number in the argument of a logarithm, and since the argument of a logarithm cannot be negative, that means that this solution must be extraneous. So now let's check the other solution, which is that x is equal to 2. We'll plug 2 into the x values and then see if this makes a true statement. So we have the log base 10 of 2 plus the log base 10 of 5 is equal to 1. By the product rule, we know that log base 10 2 plus log base 10 5 is equal to log base 10 of those two arguments multiplied together, which is 10, and the log base 10 of 10, remember this is an implied base 10, is actually equal to 1. So this answer does work. Let's look at one more example. The first thing that we want to do is condense the logs on the left-hand side of the equation, and since these two logarithms are being subtracted, that means that their arguments are going to be divided, where we have the first argument in the top and the second argument in the bottom. So it's x plus 2 over x minus 4. Now that we have a condensed logarithm, it's time to convert to exponential form. So we start with the base and we go counterclockwise around. 4 raised to the 2 power is equal to this rational argument. So we have 4 raised to the 2 power is equal to x plus 2 over x minus 4. And this is 16 is equal to x plus 2 over x minus 4. And now we take a fresh look at this equation and see that it's rational. One method of solving a rational equation is to multiply both sides by the LCD. And in this case, the LCD of the equation is x minus 4, and we multiply both sides by x minus 4 over 1. On the left, we get 16 times x minus 4, and on the right, we just get x plus 2 because the two x minus 4's canceled out. Now we have an equation that's linear, and we're going to get our variable terms to one side and our constants to the other. So let's distribute the 16 into the parentheses to get 16x minus 64 is equal to x plus 2. we'll get our variable terms to the left and our constant terms to the right. So we have 15x is equal to 66. And then when we divide both sides by 15, we get x is 66 over 15, which reduces by taking out a factor of 3 into 22 over 5. Now to check this answer, we go over to our calculator. We're going to input 22 divided by 5 and store that into the x variable. We hit enter to actually cycle it through, and then we plug that value in for x back into the very beginning equation. In order to get log base 4 on our calculator, we can select the Math button, and from this first Math menu, go to the end of the list until we see log base. If we select log base, that enables us to put whatever base it is that we want. In this case, it's base 4. Log base 4 of, we've already stored 22 over 5 into x, so we can just say x plus 2. And from that we subtract. Again, we go into the Math menu. In order to get to the end of the list, it's actually a little faster to go up from the beginning. So we'll go up to option A and select log base again. Log base 4 of x minus 4 for the second argument. And now we just need to hit enter, and we see that that actually does give us the output of 2 that we were expecting. So we checked our answer using our calculator, and x is equal to 22 over 5 actually does work.